All right, so as we said last time, most of the time we can actually use an assumption slash some rounding to avoid the quadratic formula. So let's see an example of that. So in this question, it asks us what's the concentration of H plus at equilibrium in a 0.15 molar HCN solution, and then it also gives us the value of Kc. And so naturally you want to start off with your Rice table. So RICE. And then we're already given the equation. Next thing we want to think about is what our initial concentrations was. Well, it only gave us one concentration. And so we can write the 0.15 molar right in here. We're going to assume that the reaction just started. So these other ones are going to go ahead and be 0. And then we think about the change. We just started the reaction. So our reactants are going to turn into products. So this will be negative X, and then the products will be plus X. All coefficients of 1 because the stoichiometric coefficients are 1. For line E, we add up line I and C. So we do 0.15 minus X. And then here we just have X and X as well. Next up, we want to write our expression for K. So here we say K is equal to the concentration of H plus times the concentration of Cn minus divided by the concentration of HCN. And then we can plug these numbers into here, plug that into there, plug that into there, and then 0.15 minus X into here. So what we end up with is X times X is equal to 0.15 minus X. And so we're also given the value of Kc, so we can say that this is equal to 4.9 times 10 to the negative 10. And so now if I continued this problem, it would end up being a quadratic formula type of problem. And so to avoid that, we can make an assumption here. And our assumption here is that K is small. That's not an assumption, that is true, right? This is 10 to the negative 10, right? So that's 0.090, right? 49. So the K is very small. And so if K is small, then the amount of products that you're going to have is small. And that's equal to X, which means X is small. And if X is small, then 0.15 minus X, right? A number minus a very, very tiny number is approximately equal to just that number, right? And that's the assumption here that we can use. So when using this assumption, you want to write something like this. And so what that allows us to do is get rid of this minus X. And so we can rewrite this as X squared is equal to 0.15, or X squared divided by 0.15 is equal to 4.9 times 10 to the negative 10. And then we can just continue and solve for X. So we're going to multiply both sides by 0.15 and then take the square root. If you do that, you should get 8.6 times 10 to the negative 6 molar. And so we have to check the assumption. And the assumption here is that X is within 5% of the original number, right? In this case, 0.15, right? So if we take 8.6 times 10 to the negative 6 divided by 0.15 multiplied by 100%, this number needs to be less than or equal to 5%. In this case, it is. It's not even close, right? It's a very tiny fraction of this number. And so if it's within 5%, your assumption is valid. And you're kind of allowed to use this. Cool. So there's the assumption right there. If the assumption isn't valid, then you'd have to go through the quadratic formula. And then what the heck was this question asking? Oh yeah, this question was asking for the concentration of H plus at equilibrium. We see that this is equal to just the value of X, which we have right here. So this is our concentration of H plus, and we've finished the problem without having to use the quadratic formula.